I didn't say that. There is no point in putting chocolate on your study guide. Put that in your mouth, okay? Okay, let me get pointer options first. Pen, and then I need light, oh no, I'm going to get white screens. So I need dark ink color. And, okay. So the first request was number 7. Move. Writing molecular ionic and net ionic equation. Okay. Do you have an example from the previous exam? This must be from your exam 2. If anyone has exam 2 and if you have that question, we'll just do it again. Or if you have some other example, whatever. So now you know which question. So be ready with what, if a particular example you want me to do. Otherwise, I'll just choose anything.
Would you like me to spread all of the exams out to you?
No, you can just tell me what's the question. You can just read out and then, I can just write it down. Writing ionic, net ionic. Yeah, it must be in exam 2. Yeah, you just give me the question. Let me just write it down. AgNO3. Physical state is given as AQ. Okay. Plus KCl. AQ. Okay. So on a typical question, this is what will be given to you. The two of the reactants and their physical states. Okay. And you need to write the balanced molecular ionic and net ionic equation. So the first step is to complete this reaction. Remember, for writing balanced ionic net ionic equations, you will be always given a double displacement reaction. So first step is do the double displacement, figure out what are your products, and then solubility table will be given to you. So using the solubility table, you will figure out what are the physical states of the product. So first let us do the double displacement. Here what could be your products? So AgNO3 is, silver is positive, NO3 is negative, K is positive, Cl is negative. Double displacement means what happens? They swap their places, right? Okay, so now Ag will take up which ion? K or Cl? Cl. Remember, positive and positive cannot attract, correct? So the Ag is positive means that has to pick up the other negative ion. So you have AgCl, and what could be the other product? KNO3. Okay. Now pick up the solubility table and tell me what are the physical states of these two products. Solubility table, use table from your book, or if you still have that attached to your exam. AgCl is a solid. When you look at the solubility rules, it says that chlorides are soluble, but there are exceptions, and silver chloride is one of the exceptions. So that means AgCl is a solid. And how about KNO3? Solubility rule says all nitrates are soluble. That means potassium nitrate is soluble, or in other words, AQ. Now we have to check. So this is the molecular equation. When you complete the equation like this, this is the molecular equation where we are writing the molecular formulas of each species. Is this equation balanced? We have to check. That is the last step to check in the molecular equation once you get the physical states. Equation is balanced? Yes, it is. So this is first step, balanced molecular equation. Now we have to write the ionic equation. When you have the molecular equation, rest of the steps are very easy. What is it we have to remember when we write the ionic equations? Ionic equation means write species in terms of its ions. But what is it we need to remember? What? You will not touch solids, anything with parenthesis liquid or gas, or in other words, so what is the only other physical state left if you cannot touch solid, liquid and gas? Only AQ is left. So from the molecular equation, if any species is left with AQ, you have to split them into its ions. That will give you the ionic equation. Rest of the things write as it is. So silver nitrate is AQ, so we have to split it. So we are writing the ionic equation now. What are the ions in silver nitrate? You have to write them, ionic means you have to write them with the correct charges. Ag plus, and to be more accurate, you have to put the physical state also with each ion, because those ions are dissolved in water. So Ag plus and NO3 minus from silver nitrate. Then from KCl, what are the ions we have? K plus and Cl minus. So we have done the left side. On the right side, AgCl is a solid. Do I split that? I do not. So I can just write AgCl solid. Don't touch it. Write it as it is. KNO3 is aqueous. Can we split that? Yes. What are the species we get when we split that? K plus AQ and NO3 minus AQ. Okay, so we have the ionic equation. This is the ionic equation. You split everything with AQ as a parenthesis. Do not touch solids, liquids and gases. Now we are ready to write the net ionic equation. How do you get the net ionic equation from ionic equation? You have to get rid of something. What are we getting rid of? Spectator ions. What are spectator ions? Ions which exist on both sides, exactly as it is. Not just looking at the formula of, oh, Ag is there, both sides. Not like that. Exactly as the species. It should be existing on both sides. So compare one by one. You have Ag plus AQ on left side. Do you have Ag plus AQ on right side? You don't. Therefore, this is not a spectator ion. NO3 minus AQ on left side. Do you have NO3 minus AQ on the right side? Yes, you do. So that becomes a set of the spectator ion. Right here. You have it on left side and right side. Why is it not drawing? Okay. So that is a set of spectator ion. Exactly on both sides. How about K plus AQ? K plus AQ is on both sides. Here and right here. How about Cl minus? Do you have Cl minus on both sides? No, you don't. So these are the two sets of spectator ions. Get rid of them. Whatever you are left with is your net ionic equation. So what are we left with if we do not include the spectator ions? Ag plus aqueous. And what else is on the left side? Cl minus AQ. And on the right side we have AgCl solid. That is the net ionic equation. So this is what you have to do when you have a question like that. As I said, the starting point is only your reactants and both of them will be aqueous. And remember, it is a double displacement reaction. So first you have to complete the double displacement, figure out the physical states, balance the equation. That gives you the molecular equation. That's actually 90% of the work. Once that is done, it's just looking at that, you are writing down the next two steps. From the molecular equation, anything with AQ must be split into its ions. When you split, make sure you write their correct charges. You will have that chart which has the charges of all the polyatomic ions and some of the monoatomic ions. Otherwise, monoatomic ions charges you should be knowing from the periodic table. Once you have the ionic equation, check both sides carefully. Whatever ions exist on both sides, you have to identify them, circle them, put a line across, something to identify them so that you can eliminate them for the next step. Okay? All right. So the next question you requested is number 8. Mole ratios, identifying limiting reactant, calculating the amount of product that would form in a chemical reaction. Okay, let me get a new page again. Right. Do you have a question for me, or we can just choose a question that's from chapter 6? Okay. Identify the limiting. How about question number 6.49 in page number 239 in your book? It's from one of the end of chapter questions. Usually in this type of problems, I will give you the balanced equation. Okay? In this question, the balanced equation is not given, but we will write that. So it will give you an extra practice on writing balanced equation also. But rest of the things are the same. Both reactants, you have the masses given. First you have to, of course we have to write the balanced equation in this question, but as I said, that I will give you. We have to identify the limiting reactant, and here the question is, will the solution be acidic or basic when the reaction is complete? I'm slightly changing that, or in other words, all I'm doing is I'm taking those quantities from that question, that's all. What we will do is 6.49. Let me see if I have a better question, like, you know, exactly what you would see. Limiting reactant and 2 grams of Na is added to 10 grams of H2. Okay, probably 6.46 is a better question, guys. That would be a typical question you would get in your exam, where the balanced equation is given. We have to identify the limiting reactant and then mass of one of the products, and we have both the reactant masses given. Okay, let's look at that one, 6.46. That is your typical question. So the balanced equation is 2 sodium with 2 water giving 2 sodium hydroxide and H2 gas. Let me write that first. So 2 sodium plus 2 water giving us what? 2 sodium hydroxide and H2. Now if you put the physical state, this must be solid, this must be liquid, this must be aqueous, this must be gas. So the balanced equation given to you, and the other two quantities given to you is the mass of the reactants. Sodium 2 grams, 10 grams of water. So you are given 2 grams and 10 grams. That's all is given in your question, okay? And typical 2 steps. The first step is identify the limiting reactant, and the second step is calculate the mass of, there are 2 products, but I'll be specifying one particular product. So calculate the mass of product H2 that will form. Everyone understood the question? Okay, all right. So we are given quantities in grams or in mass units. What is our first step? Convert them to moles. Remember, you cannot do anything in a chemical reaction wherever you are using mole ratios, limiting reactants, such problems, you cannot do anything with the mass. You have to get the moles. So the first step, without even thinking about anything else, What you have to do is, as soon as you see the mass quantities, you have to convert them to moles. Okay, how do we convert mass to moles? What do we need? We need what? The periodic table to calculate what? The molar mass. Remember, molar mass, which connects mass to moles. Okay? So you need the molar mass. You have the periodic table. You all know by now how to calculate the molar mass of a particular species, looking at its individual masses from the periodic table. So, okay, first let us do the 2 grams of sodium. How do we convert the 2 grams of sodium to its moles? What do I need to do with the molar mass? Multiply by the reciprocal or divide by the molar mass. What is the units of molar mass? Grams per mole. So here you have a quantity given in grams. You want a quantity in moles. So you are looking at how can I write it so that the grams and grams will go away, right? So you have 2 grams on the numerator. So you want the other gram on the denominator. That's the only way you can cancel it. That means you have to either divide, or remember, division is the same as multiplying by the reciprocal. So 1 mole per, what is the molar mass of sodium? 22.9. Is that? Yeah. 22.99 grams. So that your grams and grams will go away and you should get your number of moles. Take out your calculators and finish that, please. How many moles of sodium you have? And keep rotating the chocolate basket if you guys need, as I said. Oh, especially difficult problem. Keep rotating. I want everyone's brains to be completely open. Okay, how many moles? 0.1% loudly. 0.87. Okay, that is the moles of sodium we have. Similarly, convert the 10 grams of water into number of moles. So we have 10 grams of H2O, and same thing we are doing, multiplying by the reciprocal of the molar mass of water. What is the molar mass of water? 1 oxygen and 2 hydrogens. 18.02 grams. So again, grams will go away. And how many moles of water we have? 0.55, did you say? Okay. 55 moles of water. So we converted both quantities into number of moles. Now we are ready to identify the limiting reactant. Well, in this question it is really easy. You don't even have to do any calculations. If you just look at the equation, that should tell you which is the limiting reactant, right? What is the equation says? What is the mole ratio between sodium and water? 2 to 2, or in other words 1 to 1. So 1 mole of sodium needs 1 mole of water, correct? So if you have 0.087 moles of sodium, how many moles of water you need? 0.087, the same amount, right? The mole ratio is 1 to 1. So all you are doing is, now you are checking whether this number is sufficient or not. Is this number enough? If you have 0.087 moles of sodium, you need only 0.087 moles of water. But you have 0.55, which is much larger quantity, right? Therefore, who has to be the limiting reactant? Who said water? Therefore, sodium has to be the limiting reactant. Remember, limiting reactant, guys, it's its logic and mole ratio. You are looking at the mole ratio from the balanced equation. It says 1 to 1. So with this number we know that you need only this much water. You have way more than that. That means water is in excess, right? When you have something extra, that means it is in excess. So water is in excess, therefore sodium is the limiting reactant. So you identify the first part, sodium is the limiting reactant. So once we get that, now we are ready to do the next part, which is how much product will form. Here the specific product we are concentrating on is H2. So the key point to remember is the amount of limiting reactant determines the amount of product that will form. Correct? So now we are focusing only on the limiting reactant and the product in question, which is H2. We are just going to focus on those two now. Okay. What does the mole ratio says? 1 to 1. Check again. 2 sodium giving how many moles of H2? What is the number in front of H2? Just 1, right? When you don't write a number, remember that is 1. So the mole ratio here says 2 moles of sodium will give you 1 mole of H2. That means you are going to calculate 0.087 moles of sodium will form how much H2. How do we calculate that? So what mole is given to you is 0.087 moles of Na. Multiply that by the mole ratio of H2 and Na. You are looking for how many moles of H2 will form, right? So that number goes on the top. So the mole ratio is 1 mole of H2 per 2 moles of Na. That's what the balanced equation says. So how many moles of Na? Moles of Na can go away and you get the moles of H2 as your answer. How many moles of H2 can form? 0.087 divided by 2, or half of that. So 0.04 what? 35. 0435. So let me take it as 0.044 moles of H2. Is that what the question is asking? How many moles of H2 will form? Pay attention. What is it asking? How many grams? Well, when it says express the answer in mass means, remember the units of mass is grams, right? Or in other words, it's asking how many grams of H2 will form. So what is it we need to do? One last step. We have the moles of H2. We need to express that in grams of H2. What do you need to do? Multiply this by the molar mass of H2. Okay. So we are multiplying that by the molar mass of H2. Molar mass of H2 is 2.016. Grams per mole. So mole and mole will go away and you have your answer in grams. So how many grams of H2 can form? 0.044 multiplied by 2.016. Remember it is H2. So that means you have to take the molar mass of H2, 2 hydrogens, right? So if one hydrogen is 1.008, 2 of them is 2.016. So how many grams of hydrogen can form? How much? 0.089 grams of H2. Definitely there will be a question like this, okay? I will give you the balanced equation and I will just give you the mass of the 2 reactants. And 2 steps you need to do. Identify the limiting reactant and then calculate the mass of one of the product. Mass of the product, not just moles of the product. So steps one more time. both reactant masses. First step is converting them to number of moles. Then looking at the mole ratio between the reactants, figure out which one is in excess, which one is limiting. Once you identify the limiting reactant, the amount of limiting reactant, the number of moles of limiting reactant determines how much product will form. So you will focus only on the limiting reactant and whatever product you are trying to figure out. So the moles of limiting reactant you have, multiply that by the mole ratio of your product and limiting reactant. That will tell you how many moles of the product will form. The question is how many grams of the product will form. So convert the moles to mass as the last step. Okay. The third question you want to do is number 2, writing formula of ionic and molecular compounds from their names. Okay, do you have examples? Give me the names and we will write the formulas. Lead 4 oxide. Give me all of them so that will give us examples of every type. Aluminum carbonate, tetra silicon, what was that? Decafluoride. Nitrite or nitride? D1. Okay, nitride. Okay, this gives us all kinds of examples. So, when we write the formulas, the basic things to remember, we need first, from the names, we have to identify what are the positive ions and what are the negative ions, right? When you write a name, remember we write the positive ion first, the name of the positive ion first, and then the negative ion. So whatever is written first, lead, aluminum, silicon, calcium, they are all going to be in the formula also as the first part, and the other part will give you the second part. So we need the ions with their correct charges, and in a formula the positive charges, the total number of positive charges must be equal to the total number of negative charges. Or in other words, in the formula the total charges must be cancelling each other, or the net charge should be 0. So start one by one. Lead 4 oxide, which one is positive, which one is negative? Lead is positive, oxygen is negative. Okay, so we are first looking at the periodic table. You figure out what is lead, what is oxide. So lead is Pb and oxygen we know that it is O. Now we have to figure out their charges. Remember, for the group 1 always will have positive 1 charge. Group 2 always have positive 2 charge. Group 3 have 3 plus. And group 4 we don't consider them for the charges. They are special. And I haven't given you any examples which involves the group 4 and ionic formulas. And group 5, nitrogen, now we are going in the opposite direction but negative. So 3 minus, then group 6 2 minus, group 7 1 minus, again group 8 is 0, or in other words noble gases, they don't form ions. So we have to remember that for the monoatomic ions. How about the transition metals? Whenever you see this Roman numerals are used in case of transition metals to indicate their charges, right? So when it says lead and then 4 in parenthesis, that means what is the charge of lead? 4 plus. What is the charge of oxygen? 2 minus. So you identify the ions first. Now you can write a formula where these charges are balanced. So if one lead is 4 plus and one oxygen is only 2 minus, to balance 4 positive charges, how many negative charges you need? 4 negative charges. One oxygen will give you 2 negative charge. So how many oxygens you need? 2 oxygens. That gives us the formula PbO2. One Pb is 4 plus and one oxygen is 2 minus. So 2 oxygens will give you 4 negative charges. So that is the correct formula, PbO2. Next one, aluminum carbonate. Aluminum is in which group in periodic table? Group 3. Therefore, what is the charge of aluminum? 3 plus. Find out carbonate ion from your ionic chart. What is the formula? What is the charge? What is the formula of carbonate ion? CO3 2 minus. Okay, now we have to figure out how many each we need to use so that we have electrical neutrality. Once you identify the ions, guys, it's just basic, number game. Just 1, 2, 3 numbers. You are just doing the positive and negative charge balancing. So 3 positive and 2 negative. Of course, if you take 1, 1, it's not going to work. Whenever we have 2 and 3, what is it we need to do? What is the number we are looking for? 6. The common multiple of 2 and 3, which is 6. So if you can get 6 positive charge and 6 negative charge, it's neutral, right? In order to get 6 positive charge, how many aluminums you need? 2 aluminums, because 1 aluminum is 3 plus. So to get 6, you need 2 aluminums. And to get 6 negative charge, how many carbonates you need? 3 of them. Okay. Now carbonate is a polyatomic ion. I need 3 of them. Where will I write the next 3? Remember, this 3 goes with the formula itself in the carbonate, right? Can I just write a 3 outside? No, I need to put the polyatomic ion in parenthesis and then write the number outside. This specifies that I have 2 aluminums in there and 3 carbonates in there. So the total charges is 6 positive, 6 negative, so it's neutral.
So in this case,
All polyatomic ions, if they exist more than 1. If there is only 1 polyatomic ion, just 1, then you don't have to put that in parenthesis and write 1 outside. If there is more than 1, then you have to put that in parenthesis and write the number outside. Say for example, if you are writing the formula of barium sulfate, Ba is 2 plus, SO4 is 2 minus. So when you write the formula, how many each we need? Yeah, 1 each. So we have BaSO4. SO4 is a polyatomic ion. Am I going to put that in parenthesis in this case? No, I don't, because there is only 1. When a polyatomic ion is present only 1, you are good. Just write as it is. If it is more than 1, then put that in parenthesis and write how many outside. Okay, tetrasilicon decafluoride. Is that an ionic compound? No, it is not. It is a molecular compound. Remember, molecular compound do not follow any of these charge rules. So we use those Greek prefixes in front of them to specify how many are there. So all we need is, what is the meaning of tetra? What is the meaning of deca? What is the meaning of tetra? 4. Remember, I told you guys to by heart or memorize the first 10, right? What are they? Greek prefixes? Mono, di, tri, tetra. 5 is what? Penta. 6 is hexa, hepta, octa, nona, deca. Okay, so remember that 10. So tetrasilicon means there are 4 silicons. So silicon is Si, there are 4 of them, and decafluoride, that means fluorine is F and deca means what? 10. Si4, F10. Remember, those Greek prefixes are used only in molecular compounds. Do not use them for the ionic compounds. That is one of the mistakes people do. Oh, it's easy. Just put the names, when you see the ionic formulas, just write tetra, sodium, deca, bromide. No, we don't use that in ionic compounds. Okay, the last one, calcium nitride. Of course, it's an ionic compound. So once again, we want the ions. What is calcium ion? Ca, and what is the charge? 2 plus. Calcium is in group 2. Nitride, pay attention. It's not nitrite or nitrate, it is nitride. So which one is this? The nitrogen, nitrogen, oxygen, how do the ending change? To ide, right? Nitrogen become nitride, oxygen becomes oxide, chlorine becomes chloride, bromide. Remember in the periodic table, the ending of monoatomic ions, the negative ions, ending will change to ide. That is what this one is, nitride. So that is N, and what is the charge of N? 3 minus. So once again we have to balance the charges, 2 and 3. So the common multiple is 6. To get 6 positive charge, how many calciums you need? 3 calciums. So you have Ca3. To get 6 negative charge, how many nitrogens you need? 2. So N2. Revise all those rules from chapter 2. Okay, this was all in chapter 2. Writing 2 and 3 probably. So if you don't remember those, how the ending change, rules, just go ahead and revise them. Okay, that was your third one, and the fourth one I have marked as Lewis structure, resonance structures, and molecular shape. Look for the questions, guys. So that is number 11 on your study guide. Do you have an example for me? Drawing Lewis structure and resonance. Give me something which has resonance also. In your last exam, one molecule should have resonance. I think it was carbonate. Is that one of the question was? Okay, let's use that one then. CO3 2 minus. So we want Lewis structures, then we want resonance, and then we want the molecular shape also. Okay, this will be the final exam. This will be the 3 things you have to do with the molecules. Resonance, what I would usually do is I will give you 2 molecules. One will have resonance, one will not have resonance. Okay, so this one CO3 2 minus has resonance. Anyway, first we have to do the Lewis structures. So how do we do the Lewis structures? Everyone remember that? First we need the number of valence electrons, then we need the skeleton, and we need to arrange all the electrons, right? Okay, how many valence electrons we have in CO3 2 minus? 1 carbon, so 4 plus oxygen's valence number is 6. Oxygen is in group 6. So 3 oxygen means 18, and there is 2 negative charge. What do you do with the negative charges? Add 1 for each negative charge. That means add 2. Okay, so what do we get in total? 24 electrons. So we have to show 24 electrons in our structure. CO3 2 minus, who goes in the center? Carbon. Remember, if carbon present, no need to look around. Carbon is going to be in the center. And who cannot be the central atom? Hydrogen can never be the central atom. If there is no carbon and hydrogen, how do you decide who goes in the center? The one who has the least electronegativity goes in the center. That means you need to remember the trends in electronegativity in the periodic table. What is the trend? Do you remember if you have the box, how the arrows goes for electronegativity? What does it do from left to right? Left to right increasing, from group bottom up increasing. That means the diagonal arrow is how? Left to right, like from cesium to fluorine, it's going up. Cesium is on the left side, the lowermost, and fluorine, remember fluorine is the most electronegative element. Okay, so here carbon goes in the middle, and then we have 3 oxygens, so we put them on 3 sides. Doesn't matter whether this oxygen is on the top or on the bottom, whichever way you want, but just put 3, and we connect them with one single bond. Each single bond contains how many electrons? 2. Okay, so we have used 6 electrons so far, so keep track of electrons. We used 6 so far, so we have 18 more. Now, where do I start putting the 18? Remember the octet rule, right? Start satisfying the peripheral atoms first. Do not start with the central atom. So keep the central atom for the last. So if you start with the peripheral atom, each oxygen need how many more? 6 more. So or in 3 pairs. So give each oxygen 6 more. All oxygens are happy now. And how many electrons we have used so far? All 24. What is wrong? Carbon is not happy. Carbon doesn't have an octet. What can we do? Do we have any more electrons to put? We don't. So what do you do in this case? We ask one of the oxygens to share a pair of electrons between carbon and that oxygen. That means it's up to you. All oxygens are equally important. So whichever you choose, let's say this guy, that's what we are going to make him share. So that means now you have a double bond between that oxygen and carbon. So this oxygen has only 2 pairs now. The others have 3 pairs. We have all 24 electrons and everyone has 8. Now remember, if it is an ion, even though you were not strictly following that, remember if it is an ion, usually you put that in square bracket and you write the charge outside. Okay, this is the most accurate way of representing that. Even if you didn't do that, I didn't take off any points for the final, but I didn't take off any points from the last exam. But remember, if you have an ionic stuff, you should put that in square bracket and write the charge outside. Now, can it have resonance? Yes. Remember, this double bond could be between this oxygen and this carbon, or this oxygen and the carbon, right? That means how many more resonance forms you can have? 2 more. Just for the ease of writing, I'm just putting the structure, the skeleton structure. So you can have a double bond there and single bonds on these oxygens, or you can have the double bond here and single bonds between these oxygens. So that gives you the 3 different resonance structures. Now the last part, we have to identify the shape of this molecule. How do we identify the shape? We are going to focus only on the central atom. We have to count the electron pairs around the central atom, and that will give us the parent structure. And then if you have lone pairs on the parent structure, we have to eliminate them, and that will give you the actual shape. So what I am asking is the actual shape of the molecule. Let's focus on the central atom, carbon. How many electron pairs are there around the central atom? 3 electron pairs. Remember, when you count the electron pairs or electron domains for the central atom, double bond and triple bond count as 1 domain only. So even though if you count the number of electrons, there are 8 electrons around this carbon, but when you count the electron domains for the geometry, there are only 3, because the double bond count as only 1. So if you have 3 electron domains, that gives you what parent geometry? Trigonal planar. Now, the actual shape is by envisioning without any lone pairs. Do we have any lone pairs on the central atom? No, we don't. So we don't have to do anything, right? So what is the actual shape of that molecule? Trigonal planar. Okay, say for example, what I'm trying to say is, let's say if you are doing SO3 2 minus, I think you will get a structure like this. Okay, so here if you count the electron domains around sulfur, how many are we counting? 4. Remember, each lone pair count as 1, then each single bond count as also 1. So you have 4 domains. 4 domains means what is your geometry? Tetrahedral. Oh. Now we have to decide the shape of the molecule. To decide the shape of the molecule, remember we have to envision this without the lone pair, right? Because this doesn't contribute to the shape. So if you remove from a tetrahedral, if you remove 1, what is the shape you get? Trigonal. Oops. Pyramidal. Remember that 3 of them is, that central atom is like raised above the level, right? So that's kind of the pyramidal. So that will be trigonal pyramidal. Okay, what else? That was number 4. Number 5 is question number 12, molarity converting to grams moles. Okay, that was from which chapter? That was after the exam. So it must be from chapter 11. Yeah, it should be in 11. So you don't have a question on your old exams, so we will take something from the book. Well, that's chapter 10. Yep, chapter 11, acid-base titrations. That's section 4 which we covered. Let me pick up an example. Solution process, solubility, measuring concentrations, quantities of reactions that occur in aqueous solutions. Okay. H2so4, NaOH, all are H2so4, NaOH question. Okay. So page number 455. .75, 76, 77, 78, all are acid-base titration molarity questions. So, and all of them are H2so4 and NaOH. So I guess it doesn't matter which one we do. We'll do the 75, the first one. What volume of 0.1050 molar NaOH is required to neutralize 20 ml of 15 molar H2so4. Well, wait a second, that is asking for the volume. Even though it's the same concept, I think I will be asking for the molarity. So let us do 77 or 78. 77 reads as 20 ml H2so4 is titrated with 0.9854 molar NaOH. 35.77 is required to neutralize. What is the molarity of the H2so4? Okay, that's a good one. 77. Okay. So your typical question also will be like that. I think the only difference is here you have to write the balanced equation, but in your exam I will give you the balanced equation. Okay, so that is 11.77. which will correspond to question number 12 on your study guide. So the reactants are H2so4 and NaOH. So we have to start with a balanced equation between NaOH, aqueous, and H2so4, the acid and base, base and acid, as in the order I have written. And remember, acid-base titrations, neutralization reactions. What will be one of our product? Water. Yes. So we can write that H2O. And what will be the other product? Remember, this is also double displacement reactions. So if OH and H is gone, then what are the other two species? Na and SO4. Okay. Now remember, Na is what charge? Na is in group 1. So what charge? 1 plus. Keep that in mind. And SO4 is a polyatomic ion with what charge? 2 minus. Okay. So if I just write NaSO4, is that correct? It is not. If SO4 is 2 minus and Na is only 1 plus, what should be done? There should be 2 NAs. So the formula is Na2SO4 aqueous. Now we need to balance the equation. I see 2 NAs on the right side, only 1 on the left side. So put a 2 in front of NaOH. Okay. How about the other things? SO4, SO4. How many hydrogens I have on the left side? H2 and 2H from the NaOH. So I have 4. What do I need to do? I need to put a 2 in front of water also. And 2 oxygens on right side from water, 2 oxygens from NaOH, SO4, SO4 is counted. Is the equation balanced now? Yes, it is. So in your exam, I will give you the balanced equation. So this step is done for you. Okay? But rest of the question, the quantities given, they will be exactly the same. Now let us focus on the question. What is given to us? Remember, in an acid-base titration, the number of moles of the acid and number of moles of the base, they are neutralizing each other. And how many moles of the acid you need for how many moles of the base, that clue you get from the balanced equation. So once you get the balanced equation, that is what you have to focus on. Here H2SO4 is the acid, NaOH is the base. What is the mole ratio? 1 mole of H2SO4 need how many moles of NaOH? 2 moles of NaOH. Keep that in mind. Now we are going to see what are the quantities given to us. So 20 ml of H2SO4 is titrated with 0.9854 molar NaOH and 35.77 ml of NaOH is required to neutralize. So in this such type of problems, guys, always molarity of one species and the volume of the same species. Okay? Molarity and volume of one species will be given to you, either the acid or the base. And for the other species, volume will be given to you and you will have to calculate the molarity. Okay? So here for NaOH, we are given the volume and the molarity. For NaOH, it says you have what is the number? 9854. 9854 molarity means, remember, moles per liter. That's what molarity means, right? So as I said, always rewrite molarity as moles per liter when you do a problem. So you are given the molarity and the volume of NaOH also. What is the volume? How much NaOH you are using? 35.77 ml. Do we use ml in your molarity calculations? No, we use liters. So convert that to liters and write. So how many liters of NaOH are you using? 0.03577. So these are the two quantities given for NaOH. Okay? Look at these two quantities. We need the number of moles of NaOH. What do you need to do to get the number of moles using these two quantities? What? Or in other words, multiply these two quantities, molarity and volume. You get the number of moles. Right? Remember in acid-base titration, as I said, you need the number of moles. So you just have to multiply these two because liters and liters will go away and that will give you the number of moles. So how many moles of NaOH you have? .035 moles of NaOH. Right? Okay. Now we can go back to the balanced equation. What does it say? What is the mole ratio? 2 moles of NaOH will need 1 mole of H2SO4. Right? If you have 0.035 moles of NaOH, so how many moles of H2SO4 you need to neutralize? What do you do with the 2? Okay, let's do it by the mole ratio. So you have 0.035 moles of NaOH. You want to figure out how many moles of H2SO4 you need. So what number goes on the top? The number of moles of H2SO4, which is 1 H2SO4 per how many moles of NaOH? 2 NaOH. Okay, tell me how many moles of H2SO4 you need. Zero 0.16 moles of H2SO4. How much? Oh, it's 35 divided by 2. 0.00,
No, 0.0175.
which is 0.018. Okay. So this is the number of moles of H2SO4 you need, right, for the neutralization reaction. Because look at the neutralization reaction. Whatever the moles of H2SO4, you need double the moles of NaOH. And that's what these two numbers are. This number and double that number is this number, right? Now the question is, what is the molarity of H2SO4? Molarity is what? How do we write molarity? Moles per liter. So you need two quantities, moles and liter. Do you have those two quantities now? You do. You just calculated the moles of H2SO4, which is 0.018. That is the moles. And how many liters of H2SO4 are you using? It says 20 ml in the problem. So convert that to liters, which is 0.02 liters. So that will give you the molarity of the H2SO4. So what is the molarity? 0.9 m H2SO4. So the concept is, guys, acid-base titration means at the neutralization point, the number of moles of the acid and the number of moles of the base should follow the mole ratio from the balanced equation. And either for the acid or for the base, molarity and volume will be given to you. So in this case, for the base, this molarity and the volume was given to you. So using the molarity and volume, when you write this, it's very clear. All you need to do is multiply the two quantities. You will get the number of moles of the base. Then looking at the balanced equation, using the mole ratio, figure out how many moles of acid you need. The volume will be given to you in the problem, like this quantity. The 20 ml was given to you in the problem. So once you get the number of moles, all you need to do is moles per liter is molarity. That will tell you the molarity of the other species. I think we can do at least one more problem before we stop. So what was the next one? Calculating mass percent from composition. Well, somebody requested that, so you requested the mass percent? Oh, okay, then. Okay, we will do that then. Mass percent is number 3. Where is my pen? Oops. I don't need that. Go away. Go away. Okay. So mass percent, all we need to remember is percentage of any element E is mass of E divided by total mass of sample multiplied by 100 to get the percentage. That's all you need to do. Do you have a sample question for me? There is no complications whatsoever in this one. If you just remember this. I think it should be in one of your second exam questions. Give me the question fast, guys, so that we can look at one more. Otherwise, I'll just make up a question right now. Okay, here it is. Iron oxide. You have 5.7 grams of iron oxide and 3.2 grams is iron. What is the mass percent of both iron and oxygen? That's my question. What do you do? So this is iron oxide. This is the well, I should specifically say what iron, right? This is iron 2 oxide. Well, in the formula you don't have to. Yeah, that is iron 2 oxide, FeO. So I have 5.7 grams of this substance, and I'm giving you that it's among the 5.7, 3.2 is iron. So how much should be your oxygen? 5.7 minus 3.2, right? What is that? 2.5. So you have 2.5 grams of oxygen. Now you just have to do the mass percent of each. Percentage of iron is, how do you calculate that? Mass of iron, which is 3.2 grams, divided by total mass, which is 5.7 grams, multiply by 100. That will tell you percentage of iron. Now, how about the percentage of oxygen? Mass of oxygen is 2.5 grams divided by total mass is 5.7 grams multiplied by 100. It's one of the easiest questions. What else? Let's do one more. So that was 6, 7, converting mass to moles and moles to mass. I think we did that as a part of your limiting reactant problem. Do you want to do it again? It's just a side step now, right, in the limiting reactant problem. So what else you want to do? That's all I marked. I think we can do one more and then you can do the evaluations in 5 minutes. Abbreviated configurations. Abbreviated configurations, all you need to remember is whatever the atom you are trying to write the configuration, use the noble gas before it and then write the rest of it. Say for example, white, which question is that? What is the number? Number 9. Okay. Say for example you want to write the configuration configuration of strontium, SR. Everyone knows how to write the complete configuration, right? Okay, so if you want to write the abbreviated configuration, First you need to figure out which is the noble gas before SR. Which is the noble gas? SR is number 38 on your periodic table. So the one before that is krypton. So we put krypton in square bracket. Now we need to write the configuration only after krypton. We don't have to write anything up to krypton. So SR is in which period? 1, 2, no, period, not group. 1, 2, 3, 4, 5, right? So we are starting with what? On the 5th period, what are we starting with? 5s, and the 5s1 is the first one on 5th period, which is Rb, rubidium. Sr is the second one, so what it will be? 5s2. This will be the abbreviated configuration. If you are to write the complete configuration, then you are writing 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After 4s2 comes what in the periodic table? 3d10, then 4p6, and then comes 5s2, right? So if you look at this, this is what we have given in square bracket as krypton, because that is the configuration of krypton. Only noble gases are used in abbreviated configurations. Remember that. Okay. Any short questions? All right. Then we will stop right here. And